Welcome to Cambridge Chemistry channel with Sarvat Ahmed. Be sure to like the video and subscribe the channel. Really helps the channel to grow. In this video I will be solving October-November 2024 9701 paper 22. Let's start. Question number 1. Vanadium, nobelium, niobium and tantalum are metals in the same group of the periodic table. The shorthand electronic configuration of vanadium in the group ground state is Ar3d3 and 4s2. State what is meant by the term ground state. Ground state means lowest energy level. Lowest energy level, or in which electrons are not promoted to higher energy level. Show the electronic configuration of vanadium using electrons in boxes notation. Ar3d3 and this is 4s2. Reduce the total number of electrons in the p subshell of the vanadium atom. Total number of electrons in p subshells of vanadium atom. So this is fourth period, so we have in p shell there are total 12 electrons. Pylopium was the suggested name for a new element discovered in a mineral. Pylopium was later found to be a mixture of niobium, Nb, and tantalum, Ta. Only one naturally occurring isotopes exist for each Nb and Ta. Number of protons are 41. So this is the number of protons, 73. So 93 minus 41 is equal to 52, and 181 minus 73 is equal to 108. Define relative atomic mass, relative isotopic mass. The mass of an isotope mass of an atom of an isotope relative to, this is carrying 1 mark, relative to the mass of the unified atomic mass unit, like, or you can write down compared to 1/12 of the mass of the mass of a carbon 12 of atom of C12 isotope. A sample of pilopium contains 90.9% biomass of Nb and 9.1% biomass of Ta. Calculate the theoretical relative atomic mass of pilopium based on these data. Table 1.1. Give your answer to 2 decimal place. 92 point one 80.95 into 0.091. So let's calculate. This is 90.9 into 92.91 plus 9.1 into 180.95 divided by 100. This is equal to 100.92. So the theoretical relative atomic mass of pilopium is 100.92. Question number 2. Oxygen is a group 16 elements. Write equation for the reaction between sodium and oxygen. Sodium plus oxygen is diatomic, so to form Na2O. So this is, and sulfur plus oxygen O2 to form sulfur dioxide. Draw a dot and cross diagram to show species in aluminium oxide. Draw only this is ionic compound. The maximum oxidation state of the period 3 elements in their oxides varies across the period state, and explain the variation. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur has +1. So oxidation state of period 3, element increases across the period as the number of outer shell electron increases. Water react with both inorganic and organic compounds. Complete table 2.1 to give details of the reactions of some period 3 oxides with water. Period 3 oxides, product of reaction with water. This is magnesium oxide, and pH of solution 8 to 10. Product with reaction H3PO4, and the pH of this solution is 1 to 3. Write an equation for the reaction of ethyl nitrile with water in acidic conditions. CH3, this is CO hydrolyze plus NH4 positive ion. This is 1 moles. Draw the structure of the two alcohols formed in the reaction shown in equation 1. Equation 1, C3H6 plus water, H3PO4 to form propanol. This is 2 propanol. This is 1 propanol. Explain why alcohols are less acidic than water. Alcohols have electron donating group, electron donating group having positive inductive effect, which make OH bond stronger, and cannot ionize Part C, figure 2.1 shows the boiling points of water and other group 16 hydrides. Explain the trend in the boiling points of the group 16 hydrides H2S to H2Te. Water, oxygen is strong electronegative element, so that's why it forms a hydrogen bond, H bond. So that's why it has higher boiling point than H2S, H2SC or H2Te. The boiling point increases as the number of electron increases from H2S to H2Te. The ID force increases while water has explain why the boiling point of water is much higher than that of H2S. Water molecule have hydrogen bonding between its molecules, which is stronger than ID forces present in H2S. Question number 3. Nitrogen and phosphorus are elements in group 15 of the periodic table. Nitrogen is found in inorganic compounds such as nitrogen oxide, NOx, nitrates, and nitric acid. Identify one natural and one man-made occurrence of nitrogen oxides in the atmosphere. Natural is lightning and thunderstorm. And man-made is internal burning of fuel in internal combustion engine. Write an equation to describe the role of NO2 in the direct formation of acid rain. Nitrogen dioxide plus water plus oxygen to form nitric acid. Peroxyacetyl nitrate PAN is a component of photochemical smog. Describe how PAN forms from NO2. NO2 reacts with unburnt hydrocarbons to produce PAN. Nitric acid reacts with basic oxide to form nitrates. Write an equation for the reaction of nitric acid with calcium oxide. Calcium oxide plus nitric acid to form calcium nitrate and water. Describe what is seen when solid calcium nitrate is heated strongly. Calcium nitrate decomposed to form calcium oxide plus nitrogen dioxide plus oxygen gas. A common test for nitrate is reaction with sodium hydroxide and aluminum. Equation 1 shows the reaction. Equation 1, nitrate plus aluminum hydroxide water to form this compound. Reduce the oxidation state of nitrogen in NO3 minus. NO3 is equal to minus 1. Nitrogen X plus 3 minus 2 is equal to minus 1. X minus 6, X is equal to plus 5. So nitrogen oxidation state is plus 5. Identify the species that is oxidized in equation 1. Aluminium is oxidized. Ammonia is a basic gas. Describe how ammonia is able to act as a base. Ammonia accept proton like plus H positive to form ammonium ion. Suggest the shape of the aluminum tetrahydroxide. So this is tetrahedral. Shows a sketch of some of the ionization energies of phosphorus P. This is ionization energy. Represent the third ionization energy of phosphorus. Complete the graph in the figure 3.1 to show the third to sixth ionization energy of phosphorus. Complete table 3.1 to show the properties of nitrogen and phosphorus in their standard states. Electrical conductivity, poor. Nitrogen is a gas, so it is poor electrical conductivity. Type of bonding, covalent and simple molecule. So type of bonding is in phosphorus is also covalent, and this is also a simple molecule. A form of solid nitrogen has a lattice structure similar to a solid iodine. Identify the type of lattice structure of solid nitrogen. Simple molecular structure. At very high temperature, phosphorus can form P2 molecule. P2 contain a triple bond. Describe the formation of P3 in terms of orbital overlap. One of the bond is sigma bond, which is formed by linear overlap of p orbitals. The two bonds are pi bonds, which are formed by sideways overlap of the p orbital. The bond energy of triple bond P is 485 kilojoule per mole. The bond energy of nitrogen is 944 kilojoule per mole. Compare the reactivity of phosphorus and nitrogen. Explain your answer. Phosphorus is more reactive than nitrogen, as it is easy to break the as it required less bond energy. Question number 4. Bromoalkanes are used widely in industry, although there is increasing concern about their environmental impact. Figure 4.1 shows reaction scheme involving 1,2-dibromoethane. So this is reaction 1, this is reaction 2. it is converted in reaction 2, it is converted into A in reaction 3. This compound reaction 4, an excess of complete 4.2 to show the mechanism for the formation of 1,2-dibromoethane in reaction 1. The enthalpy change of reaction delta HR is minus 90 kilojoule per mole. The enthalpy change of formation of ethane is delta HF is this. Calculate the enthalpy change of formation of 1,2-dibromoethane. Ethene plus delta H reaction 1 plus hydrogen plus Br. So this is this is 52.2 plus minus 90.0. This is equal to 37.8. Complete figure 4.1 to draw the structure of compound A. Compound A is, this is compound A. In reaction 5, compound B reacts with an excess of sodium hydroxide dissolved in ethanol. The products are HBr, H2O, and an unsaturated hydrocarbon D. Suggest the identity of D. in excess of this is name is bromo ethene. HBr and water and D is formed.